When people first drop Codex into an existing project, the first prompt is often something like, optimize this codebase. Or even shorter, just build this feature for me. That sounds efficient, but it is also the easiest way to create a huge, risky diff. Codex does not yet know why the project is shaped this way, which files are sensitive, or what the team has already learned the hard way. When you say optimize, Codex may here refactor the architecture. What you actually meant was make one page load faster. When you say build login, it may build a form, while you need API behavior, error states, redirects, permissions, and tests. So the core idea of this video is simple: do not let Codex write code immediately. Let it take over the project first, then let it make changes. Think of Codex as a new developer joining an existing team. On day one, you would not say, make the system better. You would explain the product context, coding rules, task boundary, and acceptance criteria. AI coding follows the same logic. Codex can execute very quickly, but before execution it needs boundaries. In old projects, the most important rule is often not what can be written, but what should not be touched. For existing projects, I use a fixed 3-step process. Step 1, read the context. Step 2, produce a plan, risks, and validation criteria. Step 3, execute in an isolated worktree. These steps are not ceremony. They reduce rework. A single wrong direction from an AI agent can waste more time than writing the change manually. Let's start with step 1, ask Codex to read the project without changing it. The biggest risk in an old project is not that Codex cannot write code. The risk is that it writes too much, too fast, before it understands the local structure. A safer opening prompt puts Codex into observation mode. You can say, do not modify any files yet. First read the README, AGENTS.md, package configuration, main directories, and relevant tests. Then ask it to answer 3 questions. What does this project do? Which directories are related to the current task? What constraints should we respect before making changes? The important phrase is, do not modify any files yet. That is not politeness. It defines the working state. Right now we are investigating, not editing. The second important part is telling it what to read. The README explains the project. AGENTS.md explains collaboration rules. Package configuration reveals the stack and scripts. Tests show how the project proves that it still works. If the project does not have an AGENTS.md file, you can ask Codex to draft one first. It can record how to run checks, which folders are generated output, and what must be validated before a change is considered done. Here is a common example. You inherit a front-end app and need to fix coupon logic on the checkout page. If you immediately ask Codex to write the fix, it may start editing the component. But the real issue might live in API fields, state management, or backend response shape. The component is only where the symptom appears. A better approach is to ask Codex to read the route, state files, PI wrapper, and tests first. After reading, it should tell you where coupon amounts are calculated, where errors are shown, and which parts might affect the final order total. This feels slower, but it saves time. It turns guessing into locating. Once the relevant path is clear, the actual code change can be smaller and more accurate. Now step 2, ask Codex for a plan, risks, and validation criteria before it writes code. Many AI coding failures are not caused by bad syntax. They happen because there was no agreement before work started. You think the task is small. Codex may interpret it as a redesign. You think you are fixing one error message. Codex may silence the error without solving the data problem. So after Codex reads the project, do not immediately say start coding. Ask for the plan first. Here is the prompt I use: based on your project understanding, propose a change plan before editing. Break it into 3 to 5 steps. For each step, name the files you expect to touch, the risks, and how we will validate the result. Do not write code until I confirm. That prompt pulls Codex out of autopilot and into collaborative development. It has to explain the intention before it executes. When you review the plan, focus on 3 things. First, check the scope. Is Codex touching unrelated files? A small request that changes 10 modules needs an explanation. Sometimes cross-module changes are real. But Codex should be able to explain why each touched area is necessary. Second, check the risks. Could this affect login state, API fields, data migration, mobile layout, caching, permissions, payments, or deployment configuration? Third, check the validation. Good validation is not the phrase "looks normal." It says which command to run, which page to open, which state to inspect, and what evidence should be captured. For a login redirect bug, validation should not just say login works. It should say, unauthenticated users are sent to the login page, successful login returns to the original page, logout blocks access to the account page, and the relevant test command passes. If Codex cannot explain scope, risk, and validation, do not let it continue. Ask it to tighten the plan or reduce the change. One useful trick is to ask Codex what it will not change. For example, do not refactor authentication, do not change API fields, do not modify the database schema, and do not touch unrelated styling. Clear boundaries make the final diff easier to review. Step 3 is execution, preferably inside a worktree. A Git Worktree is an isolated working directory that shares the same Git history as your main project. Codex can edit files, run commands, and experiment there without disturbing your primary checkout. The benefit is very practical. If the attempt goes wrong, your main working directory stays clean. You inspect the result in isolation, and only then decide whether to merge it back. For beginners, the prompt can be simple: create a separate worktree from the current branch for this task. Make the code changes inside that worktree, run the validation checks, and record what changed. When it finishes, ask Codex to report 4 things: which files changed, why the solution was chosen, which validations ran, and what risks remain unverified. Do not think of Worktree as a fancy Git trick. It is a way to lower risk. Many people are afraid to let AI touch an old project because they fear it will break the workspace. The Worktree gives the agent a lab. In teamwork, this matters even more. One worktree can handle a bug fix, while another handles a page update. They do not step on each other. But Worktree does not replace review. It only separates experiments from the main workspace. Whether the work can merge still depends on the diff, tests, screenshots, and human judgment. Put the 3 steps together, and you get a stable starter template for Codex. You can save this. We need to complete a task in an existing project. First, only read the project and do not modify files. Read the README, AGENTS.md, dependency configuration, relevant directories, and tests. Then summarize the project structure, related modules, and constraints. Propose a 3 to 5 step plan. Name the files you expect to modify, the risks, and the validation method. After I confirm the plan, execute inside an isolated worktree. When finished, report the changes, validation results, and remaining risks. Then add your specific task at the end. The point of the template is to turn AI coding from black box wish-making into a reviewable collaboration workflow. Here is one practical scenario. Suppose export reports are broken in an old admin system. A weak prompt is, export is broken, fix it. A safer prompt is, do not edit files yet. Locate the report export route, service code, permission checks, and tests. Explain the flow from button click to generated file. After Codex reads that path, ask for a plan. Step 1 might add a reproduction test. Step 2 might fix filter parameters. Step 3 might verify exported fields and permissions. Step 4 might run tests and inspect a generated file. Now your focus is not how much code the AI wrote. Your focus is whether it followed the right path and proved the bug was fixed. Another example is mobile styling. If you say make this page look better, Codex may create a lot of subjective style changes. A better prompt is, read the existing design system, component library, and target page. List only the 3 areas that need adjustment. Do not add a new UI library, and do not change business logic. Validation is desktop and mobile screenshots. Now Codex still has room to implement, but the room is bounded by the project. Do you always need the full 3-step process? No. If you are changing one line of copy, adding a tiny comment, or adjusting a very small color value, direct editing is usually fine. The process should not cost more than the task. But if any of these are true, I recommend the 3 steps. The project has history, the change crosses multiple files, you are not sure where the logic lives, or the task touches login, payment, data, permissions, or deployment. If you want the work to be auditable later, use the full process too. The project reading, plan, and validation notes become evidence for handoff and review. The final takeaway is this: Codex is not a magic wish box. Treat it like a capable new developer. If you do not give it context, it will guess. If you do not give it rules, it will improvise. If you do not give it validation criteria, the result may look right while still being wrong. My practical rule is, read the project, plan the change, isolate the execution. Next time you open Codex, do not start with write the code. Start with 3 questions. Do you understand this project? How are you going to change it? And how will you prove the change is correct? Those 3 questions are worth more than the prompt optimize this project. They turn AI coding into a workflow that can be reviewed, rolled back, and shipped.